Yo, folks, give me 2 seconds here. We'll get to it. No first races, people. I was first. Let that be clear. I'm always first. Okay. Greetings, folks. Jason here. Welcome to MicroCinema 4K, the highest quality live stream microscopy in the world. And, well, we've got just a nice, chill little session lined up tonight. I was a little under the weather this week, and I'm feeling pretty good today, but I didn't want to, go out on a big excursion or something and wear myself out. So we'll just take a look at what's in the local creek this week, and yeah. Let's see. I don't know if there's anything really specific to talk about as far as like sample collection or anything like that. Today I just kind of I went out and I got stuff like this, just vessels of water and sediment and whatnot, and I used my trusty mouth pipette to get some samples out of the petri dishes and onto slides. Yeah, good to see everybody. Stentor, coeruleus, good to see you. Teeny, Marcoscope. Hello, Amy. Hello, Face. Yeah. Well, let's go ahead and get started today with our prepared slide. And this is really exciting for me. This is the first sort of. Let's adjust this. Maybe. Oh, my camera's a little tilted. Let's do that. I think that's about right. There we go. Yeah. This is my first ever artistic diatom arrangement. No slight against Diatom Lab and their Diatom test slide, but this is a nice artistic arrangement here. So yeah, I'll put myself away and we'll look at this slide a little bit and then move on to the wet critters. Okay. So let's check this thing out. And to be honest, I cannot really identify any of these diatoms. I think these are primarily marine diatoms. They are from Oamaru, which is I guess like a very famous source of diatomite. So diatoms are frequently found in basically kind of like a fossilized mineral called diatomite, and the frustules stay in there, and you can get them out and find all sorts of very cool ones. And so this is an arrangement. This was made in 1951 by a fellow by the name of E. Wainwright. And let's give me a second here. Oh, unfortunately, it looks like microscopist.net is down, so I can't give you guys the skinny on what's going on there. Let's see. Give me 1 second. Go back to the. Oh, well, actually, we'll go ahead and do. Let's see. That should be all I need to do, and then let's find curler. There we go. Why is this? Oh, it's not totally cinched down. There we go. Here we go. We're in differential interference contrast, so we can really check out awesome diatoms. Just make sure yep, that correctly. Very good. Yeah, we're all set. Okay, sorry about that, folks. Yeah, let's take some time and just enjoy some of these diatoms. I almost bought a slide of that had some of these on there. I forget the name. The name evokes the idea of flowers, unsurprisingly. I love these, though. They're very cool. And then these square ones are super rad too. I think we can drop that down. Let me bring this over. There we go. And maybe we can even do a little bit of 40x. Now I don't know what thickness the cover glass is on this, so gonna have to play that by ear. It looks like 0.17 maybe, isn't it? Let me try going a little thinner. No, I think that was the wrong direction. Let's try this direction here. A little thicker. I think they might be kind of deeper on this. Hard to say. Wow, look at these. And then one thing you can see if you look super close is you can see these little cells here have within them little pores. So let's see if I turn that a little bit. Does that improve at all? Say. I don't know. We'll have to. I'll have to get the figure out what works best for this slide sometime. With as far as the cover glass thickness goes, I think it's just thicker than normal. And the 40x is very sensitive to that kind of thing. Yeah, these are just super cool. These little kind of star-like hexagons here. And this big bad boy here is big centric diatom. Super beautiful. Really enjoy getting these slides. Just thinking about like You know how careful these people had to have been to build them. Wow, this one, wow, this is the top of the diatom here, and you can see, so now I'm focusing down. You can see like it takes a long time for the rest of it to come into focus. So this top piece here, if we put this diatom on its side, it would be sticking up. It would be sticking like out to the side by quite a lot. This diatom has a very interesting shape, kind of a spiky. Wow, these are super cool. Someone joined the Discord. Okay, let's go ahead and we'll go back to the 10x here. No, let's take that in. Very nice. Super cool. Excuse me. Okay, let's figure out what we're going to look at first. I think we'll do this one. So we'll say goodbye to Mr. Wainwright's beautiful piece of art here. I'm going to put it back in the box so that I don't accidentally knock it down or something like that. No fun to break these expensive and precious slides. And then we will pop in our next slide. And this one I kind of deliberately made. I mean, I guess I deliberately make all my slides. But this one's got some very lovely diatoms on it. Ooh, we got a rotifer. Maybe a moderately squished rotifer, or just chilling out, hard to say. Let's take a closer look. You know, when they're squished, or at least not moving, that can be a kind of cool way to look at them. Let's see, let me just make sure we are yeah, we should be okay. All right, go to the 20x. Push this down. That. Pick this up. Push this down a little bit more. Get a nice contrast going here. Wow. Oh, it's kind of coming online here. Look at it. And look what we have as well. Oh, it's kind of on top of the rotifer. Is some Bacillaria. And look, we got some more coming into frame there. And not too surprised about that, because when I made this petri dish was full of spirogyra, and I went out today and I went into the stream. I walked into the stream, and I deliberately got a bunch of spirogyra, and I found some that had sort of just kind of brownish stuff growing on it. And I was like, oh, you know, this could have some interesting stuff going on. So then I made a petri dish, and I intentionally got some of that brownish gunk that came along with the spirogyra. And then when I looked through my stereoscope at this mass of spirogyra, it was like, it's so hard to describe. It was like crawling with life. like the spirogyra was like moving around. I was like, wait, what's going on? And it turns out that there is just a ton of Bacillaria in here. And they are very large colonies, very long colonies. Some of these colonies stretch out to multiple millimeters long. Oh my gosh, look at these things. And they, I mean, when you get a lot of Bacillaria in one place, it's interesting. It's very interesting to watch the stereoscope. It's a lot of fun to watch with the high mag compound microscope. And it's also kind of tough though, because you know, you're never really sure, like, how do I actually like get these in frame? Like, how do I best show these things? Because they're so big. Gosh, they'll look at them. A truly fabulous diatom. And yeah, so here's some of that gunk, and you can just see it is absolutely lousy with Bacillaria. So we might take some time to look at this Bacillaria in a few different illumination modes, and just enjoy them for a while. Because we've definitely had Bacillaria on the stream before. Ooh, there's a nice Gyrus Sigma, it looks like. But we've never really had this much all in one place. Oh, I guess I should mention for the people that are new here and wondering what the heck Bacillaria is. So Bacillaria are diatoms, and I'm going to assume that you know what a diatom is, even though some of you may well not, and that's okay. But diatoms typically are, well, they kind of do one of two things. They'll either grow like these are diatoms. This is Fragillaria. And Fragillaria grow in these kind of static colonies here, these rectangular colonies. And then we have diatoms like this Gyrus Sigma here. And this Gyrus Sigma is sort of a loner diatom that kind of scoots around, and it's motile, but it's sort of on its own. And then you have Bacillaria, which sort of decided to split the difference between these two standard growth patterns of diatoms. And so it is a motile colonial diatom. And each of the little segments in Bacillaria is an individual diatom. It theoretically could survive on its own as a single cell. But they all stay sort of stuck together, and when they all move in unison, they have this amazing sort of accordion like extension. And like I said, the colonies can get quite large. When it's amazing because, you know, the diatoms themselves are pretty darn thin. Let's see, I can put these under my 40x, shouldn't be a problem. I get some that are nicely right under there. Nice spirogyra there. Let's get our curler back in line. So yeah, these cells here, you know, they're really pretty thin, but the colonies themselves can stretch out to be quite long. And this kind of has the effect of like when you put them on the slide, you can see these just like hyper fine little hairs that are kind of moving around. And it's just really interesting to like look at, and when you know how like tiny they are, it's really crazy, because these are a different kind of diatom here. These like that are growing off of a Bacillaria colony. These little this little rosette. Oh my gosh, Nassulid, just too cool. Too much. And then, I mean, all these diatoms honestly are just so cool. These Fragillaria here. It's just so amazing. Oh, look at that. It's a big old Nichia sigmoides there. Those are fun to watch as well. And we got this nice centric diatom here, which may be maybe like a Thalassiocyra, perhaps. It's got this undulate valve. So you can see here, I'm going to focus, that's the top, and as I focus down, that's sort of the bottom face. So it has this sort of wavy shape on the face of this thing. And I think I can see some little like spines coming off of it or something. I want to say that's Thalassiocyra. And that's a, was that Cynura? Or not Cynura. Cerulella, rather. Just a real fun little arrangement here. A little collection of diatoms all getting together. There's another one. Diatoms are great. Let me tell you guys. I might be moderately biased in that opinion, but diatoms are pretty great. Look at those. Yeah, this is right about the right depth here. Okay, let's go back to like 10x here for a minute. Let's like poke around this slide a little bit, because there's probably some other stuff on here. I mainly remember the Bacillaria. That was like my main goal of making this slide. Oh my gosh, look at it, it's so busy. Yeah, they're just so and I am fairly certain that they are sort of light reactive. So in other words, like when you kind of like I had the petri dish when I first looked into it for a while. Like there's a lot of movement, and then I kind of put it away in a darker spot for a while. And when I came back, there wasn't as much movement. But then as I left the petri dish under the light again for a while, they seemed to kind of wake up. So I'm pretty sure that they react to light, and they move around when they're exposed to light. Wonderful. Ooh, we got a nice Closterium here. I think it was it last stream we ended with a... Yeah, it was last stream we ended with some really nice imagery of Closterium. We actually did some oil immersion go here, and we'll let this come down a little bit. But just because we did it last stream doesn't mean we can't take a look at it again. And so there we go. We have our famous little crystals in the tip of the cell, and the super active cytoplasm as well. Awesome. I like this. It almost looks like vasculature or something in there. This little web of intracellular stuff. And then I think these are called these little nodules inside. I want to say they're called like pyrenoids. Those are important for, I believe, identifying the species. Usually, like I'm always like, okay, it's probably Closterium monoliferum, but I am definitely not an expert on Closterium identification. There's a little flagellate investigating this Closterium. Tiny little flagellate. Again, we're using the 40x objective right now, so we're pretty darn zoomed in. These are always so cool. Let's see, let's pump that up, pump that down. Excuse me. I told you guys I'm sick. Ooh, there's a nice little ciliate. That's a cool one. Got like very like wiry cilia there. Check those out. So it's let me adjust this since it's right on the underside of the cover glass. This should be where we get the best imagery of it, right there. So you can see, so here it's basically walking on the underside of the cover glass. You can see its little feet, its little cilia feet. I just love that. I love watching these little single-celled critters walk around. Oh, he is really tiny. Whoop. Careful. Oh, wow, look at that thing curl. Okay, let's go back to 10x again. Okay, that's just normal. Okay. Oh, we got a little shrimpy copepod duder here. This is actually a good excuse to switch over to darkfield. And let's see, I guess we'll do it with this today. I have multiple options for that, but we'll do it like this. Something like that. Oh, we need to. It's gonna go blown out. There we go. There we go. here's our little copepod duder. So Seth is asking, are these cells roughly on the micron scale? Micron's still pretty small. I would say like that little ciliate that we were looking at was probably maybe like 30 microns long, something like that. That's very rough. Actually, speaking of which, one improvement that is in process for the stream, it's not ready yet, unfortunately, but something that is coming is kind of a scale bar that automatically switches with the objectives as I change between them, and as I like do this, as I like punch in with digital zoom and all of that. I know that a lot of people are curious about the size of things, and yeah, we will get that set up eventually. So stand by on that kind of stuff. We'll get there. Let's see, I'm gonna go ahead just because there's a good chance I'm gonna want to hit polarized light here. Pull out my differential interference contrast analyzer and put in my polarizing analyzer. There we go. And yeah, I guess actually we could, while we're here, we could do a little bit of polarized light microscopy on this bad boy. This is darkfield polarized light. You can see those eyes always glow. And let's see, we can, we'll take our polarizers out. Oops, a little bit wild there. Let's bring this down, and then let's go ahead and just go see kind of what else is going on in our slide here. Oh, we got a nematode in there too. So we get a slightly apodized image here. Actually, not very slight. It's pretty significant here with the 4x. So don't worry, we'll get the full frame going on in just a minute. Just want to kind of quickly zoom around, just see if there's anything kind of out at the edges, like that copepod that we don't want to miss. I definitely don't always remember everything that gets on these slides. Okay. Well, let's go. Where was that? Yeah, let's go here. This looks super cool. Wow. Darkfield. What a wonderful technique. Look at that nematode. Worming around in there, doing nematode stuff. And then all of our lovely Bacillaria. Yeah, and this is another thing that's really cool about Bacillaria, is that they have just this awesome like glinting that they do. Actually, you know what? Let's see. Since I'm in this mode, I wonder. I come down here. Yeah, and I get like right here. This should be like oblique. And oblique methods can work really well with Bacillaria, because they'll like catch the light in a certain way. Push this back just a slight bit there. Actually, I guess what I should do is I should have it kind of all the way. Yeah, like right there. And you can see just kind of sections of the Bacillaria will like light up depending on how they're oriented. Oh, yeah, that's so cool. And you really like, when it happens, like you really start to realize like, yeah, oh, these things really are just like little kind of bits of glass, little living bits of glass that are moving around and glinting. It's just not fully correct. They are, it's not all glass, but there's a lot of silica in there. Very fun. We got another set of diatoms there. Melisara, probably. I wonder, so let's, if I go to the 4x, oh yeah, and then we have a whole bunch of diatoms here that I totally forgot about. Yeah, this is another group of diatoms. Yeah, let's bring this just a stretch. Go. So now we're with the 20x objective here. And yeah, the name of these kind of larger cylindrical diatoms is escaping me at the moment. There's a couple different things they can be. Gosh, what is it? It will come to me later. But I think these are the ones that sort of kind of grow catty-cornered to each other. And they have a feature, they kind of link together when they catty-corner like that. This is a feature that you can like look for and know with certainty that that's what it is. Yeah, they sort of connect in this sort of zigzaggy corner to corner. Okay, let's do some polarized light. And for this, let's go ahead and take this out. There's my polarizer. So diatoms themselves don't tend to have super strong polarized light response. But I have noticed in the past that they can kind of glow red like this. And I think this is some kind of, well, to be honest, I'm not entirely sure. Because it really seems like isolated to where the chloroplasts are. So sometimes I'm like, well, maybe this is actually like fluorescence or something. I wonder, Yeah, I mean, like, look at that, right? Like, that doesn't, like, before I was, like, thinking, okay, it's structural color, but, like, this doesn't make sense for structural color. I don't know. I remain unconvinced of that. If I open this up all the way. This stuff's all very bright. The polarized light has often will have this effect as well, where sort of the outsides of things, the outsides of the cells and whatnot, will turn bright, and that's mostly like a kind of an optical, like refractive thing. It's not so much about polarization. Wow, these some of these green things are lighting up. Ooh, look! Ah! Sorry for the noises. Oh, where'd it go? Where'd it go? Come on, buddy. Where'd it go? Y'all saw it, right? Y'all saw it? There it is. There it is. It's a little cute Gastrotrich. Ah! Look at it. The Gastrotrichs. So Gastrotrichs have these scales. And the scales, I don't know if they're birefringent, but they definitely, when they're on the side like that, have a reaction to the polarized light. And oh, it's so cool. Oh, I love Gastrotrichs. Okay, we will let's see, what can we do? Let's go back to the 10x here. And we'll use the old wave plate to add a little bit of color. Yeah, and then this is the other thing too, is that, like, yeah, they're the diatoms. They show up red. Like, I don't know. I kind of enjoy this here, where we have sort of a nice subtle kind of blue-orange going on, depending on the polarization. Should check my color here too. There we go. Yeah. Gastrotrix. This is I also just like, in particular, this little species here is extremely cute to me. It has, like, it's the right size. It's a teeny little animal with a funny shape. Okay, back to here. Open that up. Okay, we'll take it on faith that we can just find this Gastrotrich again. Wow, some of these green things, like the Closterium, really show up in the polarized light too. But we got to figure out why these diatoms glow red. Oh, that's right, I forgot we have a nematode. Nematodes always interesting to look at in polarized light. Let's see here. I'm gonna go ahead. What should I do? Maybe I'll try for darkfield polarized, maybe? If I do this one, then I can't get it there. Yeah. We'll try it with this. Open that up. Yeah, there we go. That's going to be important. Okay. Sorry for the delay. Now if we just turn this. Now we're in dark field polarized light. See how that goes. Oh, there's that rotifer from before. Oh, wow. Wow, you get a really good view of the trophy inside of the mastax. That's the sort of like kind of bone-looking structures inside of the mouth part there. That's very important for identifying rotifers. And let's see. Let me find our little Gastrotrich friend again. Did I just see it? It was down here somewhere before. Couldn't have done anything like swim away on us, could it? Well, let's see. We'll open this up a little bit here. Give ourselves some more stuff to view. With that little Gastrotrich. I want to see that Gastrotrich in DIC before we leave the slide. But if we can't find it again, that's okay. Gastrotrich, where are you? Let's go ahead and we'll just take out the polarizing stuff. So you just get regular dark field. That way we don't miss anything. It's also possible that Gastrotrich has gone to sort of bury itself in some debris. Wow, get that. Like the field of view, like here I'm with the 4x objective, and like across the screen is like multiple millimeters. So this Bacillaria that you're looking at right now is multiple millimeters long when it stretches out. Wow, look at them. They're so active. You might have to abandon operation, look at the Gastrotrich more. Oh, there's our rotifer again. What is the large white area with the black spot? I do not know, to be honest. No idea. Okay. Well, we've probably spent enough time looking at this slide. This is my trick to try and find the... Ooh, these are nice. Nice, actually. Let's go back to DIC, actually. Let's do that before we go to the next slide. And we'll just take a look at like some of these other diatoms. Again, I don't think we looked at these in DIC yet. We'll check those out. And maybe the Gastrotrich will swim into view. Grace us with its goofy presence. To 20x. And heck, let's just jump right to the 40. Go. Pop that up a little bit more, pop that down. Wow. Oh, these are just so neat. I really love looking at these frustules with these incredible poroids. Diatoms aren't like glass canisters, you know, that nothing can get out of. If diatoms were all locked up inside of a impenetrable glass shell, then they couldn't do things like, you know, cellular respiration and all that. You know, they couldn't actually live. And you need to be able to exchange stuff with the outside world. And so most diatoms, when you look at them up real close, you'll see they have these pore structures. And so they're more like, you know, screen meshes of glass surrounding these plastids. Yeah, and then you can see here, this species of diatom, the ones that sort of catty-corner together like this, they have this little like kind of mucus node there where they link together. That's an important feature when you're looking at these. Yeah, the plastids in these are really cool to look at. Pleurosira? Is it Pleurosira that I'm thinking of? Yeah, Pleurosira is what these might be. But I'm to be honest, I'm not entirely certain. Like some of them seem to be extra long, but maybe those are just in the process of dividing. I don't know. I love them though. They're very cool. So this is a lone little Bacillaria here. Poor fella. It's got nobody to roam around with. Neat. Super neat. Those are rotifer that appears to be getting kind of squished. Let's see. One more quick scan around, see if we run into our Gastrotrich friend. I think it was down here, actually. We're around here on the slide. Wow. It's crazy how these things can whip around. Wow, look at them all tangled together. Just wild. Really, really interesting. Such a unique diatom. You know, out of all the other ones, like that's the only one that I know of that like has such a unique method of living. You know, or at least like just moving, kind of how it exists. It's very, very interesting. It doesn't seem to be like, doesn't seem like there's any other diatoms that necessarily do that. Oh, you know what? Actually, one more thing that I want to do is just do a little bit of bright field. Let's see, maybe one of these bad boys on there. And we just, sometimes I really do enjoy looking at slides in bright field. Just enjoying kind of the colors, you know, what I would consider to be sort of the most natural colors, the most realistic colors of the critters we're looking at. And it's, of course, you know, what a lot of folks are going to look at when what they're going to see when they first open up the microscope and start using it for the first time. And you can see you can still get really lovely stuff. Oh my God, it's the Gastrotrich. Found it. Look at it. Doing Gastrotrich stuff. Okay. So let's see, what's the fastest way to go about this? Let's pop that in. Get that in focus. We are at the 20x objective. Hello. Hello, hello. Hello, little Gastrotrich buddy. See if we can't go to the 40x. Open that up. Drive one-handed a little bit here. Not something I recommend doing on a regular basis, but you know, sometimes you're, oh my gosh, look at the little feet. It's got little feet. Look at them. Gotta keep it centered here. Oh, dipping and diving. These are just so cool. Again, these are multicellular animals here. And you can see that this one, kind of the Bacillaria, I think, are maybe around 100 microns. Maybe more like 80 microns long. And so that's kind of similar-ish to what we're seeing here. Come up on the top again. You can see that they just have these wonderful spines coming off their scaly little bodies. Ooh, look at this nice gyrosigma here. Very cool. Okay. Well, we got our little Gastrotrich boy. That's cool. And there's a nice Cymbella. All right, let's move on. Okay, now to be honest, I'm not entirely certain what the state of this slide is going to be in. So I made a couple slides today where I was like really trying to make nice thin specimens, and kind of succeeded a little too well. In that I think I squished a lot of stuff, even like really small stuff. I think I squished. I used my Vaseline method, but it seems to have maybe still resulted in some unintentional squishing. So we'll see. We'll see if any of these organisms are still kicking around. Got a nice Pinnularia here. This is actually from a sample, a petri dish rather, that's a couple weeks old at this point. But I found some neat stuff in it. Still, that is a little testate amoeba there. Ah, yes, here we go. So I think we had Stentor coeruleus in the chat earlier. And we have here, actually, let's go to Brightfield, because Brightfield is probably one of the best ways to enjoy this organism. Oh, this one's so thin. It's so it's so squished. You can't really see the blue. But if you kind of squint a little bit, you can tell. Yeah, so this is Stentor coeruleus. This is a pretty small one, actually. I seem to recall I got a few of them on this slide. And so we can take a look. We'll put the DIC back in. Let's open that up. There we go. Let me do one thing just to make sure. All right, maximum extinction there. Okay, that looks pretty good. All right, there we go. Boom. And so here we go. This is Stentor coeruleus. And these things are huge single-celled ciliates. And normally they don't really look like this. This one is pretty strongly flattened under the cover glass here. But it does allow us to see this interesting little chain of beads inside of it. And that is the macronucleus. And basically each one of those little beads, those little globules, has the full like genetic code. Like it can operate as a excuse me, as an independent nucleus. Like that, maybe. Let's get this out again. There we go. Yeah. And look at that. You can even see there's some interesting structures inside of these nuclei. Some little like vacuole sort of looking things. And I, to be honest, I have no idea what those are all about. They're probably important. And here are the fluttering cilia. I guess this is what would be called the adoral zone of membranelles. If you're not into the whole brevity thing, basically cilia that are around the mouth. You'll see that shortened in literature to AZM. Adoral zone of membranelles. Oh, and this is a little, another little testate amoeba, something like an arcella. It is being sort of rolled around by the stentor. Stentor's got a little food vacuole in there. See the cilia on the top side that are right under the cover glass. And then these awesome little like I think these are basically like these lines here are what enables the stentor to have like to be contractile basically. All right, let's go back to the 10x here. Let's see what else we got on this slide. I think there should be a few stentor on here. Some of them were larger than others. Whoa. Oh. I think. Yeah. This is, I remember, I thought maybe it was that one, but I think it's this one. I plucked out a very tiny Stentor coeruleus. And I believe that's this one. It's like a legitimately like a little baby Stentor coeruleus. You see it doesn't have as long of a macronucleus chain. But since this one's smaller, it can actually like swim around a little bit. I wonder, it doesn't even really seem to be fully formed. But, you know, one of the benefits of having a macronucleus chain like that is that if you get cut in half or get a piece of you torn off and a little bit of that macronucleus chain goes along with you, then the piece that comes off can regenerate and make a new organism. So maybe this is like a little piece that got torn off of another stentor and started swimming around. And this one's just small enough that it can get a little bit of room to swim. I'm just curious, do these don't really take on any other color. Okay. Got that Stentor. Oh, yeah. And here we go. I wonder if maybe Sumi can check in at some point or watch the VOD. So this is a very flatworm. These worms were considerably more motile before I squished them onto the slide. But it does seem that they are squished in such a way that they're not like, you know, murdered. They're clinging on to life. See, this one's eating a couple diatoms. And according to Sumi, who is a worm expert on the Discord, and also runs the kind of general microscopy Discord, squishing worms to the point of not quite death is a good way to identify them. But also, you know, you have to know what you're looking for, and that is not something that I have. We can take a look at this thing. These little nodules here are probably where its body's being damaged by getting squished so much. So it's a little over squished. But there's like, I don't know, there's things like mouth parts and stuff that you can only see when you squish them. But, you know, I don't know. You guys see anything in there that is these are cool, these little cells here that are vibrating around. Probably a little like water osmotic pump cells. In rotifers there's something that looks like that called flame cells. I don't know if these have flame cells as well. It's got some of these Bacillaria inside. And you can see these flatworms are just covered in cilia, and that is how they get around. So cilia are not restricted to the ciliates, although these cilia are probably like fundamentally different in just terms of like chemical, biological structure. But just the idea of having a bunch of little hairs waving around, that is not unique to the ciliates. I do believe we have some other little worm dudes on here. Here's another one. This looks like maybe a stenostomid. And for anyone that's kind of new to microscopy, like there's sort of a theme in microscopy and like imaging of always trying to get your specimens to be very, very thin. In fact, there's a whole like practice called histology, which is basically all about making very, very thin sections of organic tissues to look at. Usually you stain them as well, but and you make these things really thin for good reason. Turns out that the thinner the specimen, kind of the better imaging that you can get on it. Usually microscope objectives are made to look at very thin stuff. They're made for histology, pretty much. Ooh, it's a paranema, a little flagellate, little white euglenid there. Investigating. Diatom frush. Looks like a Cimbella. Yeah, I think so. Yeah, so it is kind of cool every now and then to get these worms squished down a little bit, get your specimens squished so that you can use your really like high performance objectives to take a look at them. Just continue looking around. Ooh, this one is not looking so hot. Looks like kind of the same species that we were looking at before. Oh, here's another Stentor. This is a larger Stentor for sure. These Bacillaria are kind of bulldozing into it. That's an interesting little scene. Oh my gosh. They're like stabbing into it. There we go. Sorry, I'm back. Microphone cut out there. Go to the 40x here on these bad boys. Wow. So again here, just like this slide is very deliberately prepared to get very good imagery with my 40x objective here. And if you're kind of new to microscopy, you might not be so careful when you're preparing your slides, and when you use your higher magnification objectives, you might get kind of disappointing results. So a lot of people kind of end up not using their 40x or their 100x, even though really it's just an issue of sample preparation often that's leading to disappointing results. It is possible to get good imagery with those. I think these tiny little dots here are like pigment centers. And it's really cool. I was looking down here, like, so you have, this is focused on the top and we're kind of focusing down. You can see you have these like, these sort of lines here that start off slowly curving around, but then you like zoom in a little bit more and they become all twisty, like ramen. And again, I think this is basically the structure of the organism that allows it to stretch and contract. Again, we are taking a look at the lateral zone of membranelles. And there is the macronucleus chain. This one looks like it's kind of in the process of splitting into two nodes. Let's zoom out on this one actually. And let's see if this one has any kind of blueness to it. Just kind of got a shade of blue. Let's see, let's go out. Yeah, that's. Under the stereoscope, these things are intensely blue, I have to say. So unfortunately, when they're squished like this, they're so thin that the color kind of gets spread out, so you don't get to see the super nice deep blue of the Stentor. That's a note for next time. Next time, I find Stentor coeruleus very often. In fact, they do seem to be an organism that kind of is at the end of the life of some petri dishes. Like they just kind of pop up and they stick around for a while. There's another one with a great macronucleus chain. So, yeah. All right, we'll move on to our next slide here. So this is a deep well slide with a whole bunch of spirogyra on it. And some other stuff too, theoretically. But I just enjoy having a nice bundle of spirogyra every now and then to look at. Yeah, it's just such a beautiful organism. Oh no, we have a rotifer that is squished. Huh, that's bad. Be squished in here. Whoa. So yeah, this is some kind of larva that was in these, in with these, and this larva builds like little detritus tubes that it lives in. And I tried to get one of those tubes kind of out and onto the slide, but every time I would sort of mess with the the tubes, the larva would abandon them and just come out and kind of freely squirm around. But I think this is probably like what's called like a chironomid larva. It seems to be kind of slowly reacting here. A little twitchy. These things in the petri dish, they flail around a whole lot. So I don't know if this one's, I don't know why this one's being so docile. I think there's another one on here too. Oh yeah, this big boy. Let me get another little view of it. It looks like it has maybe 4 eyes. Let's see. Yeah, it does look, Gordon's mentioning a little jumpiness in the stream. That can happen, unfortunately. I don't think it's anything on my end. I think sometimes the YouTube servers just struggle with the ingest of 4K streams. So hopefully it's not too bad. Hopefully it's not unwatchable. Look, see, we have Bacillaria waking up now that they're bathed in light. It's also possible the Bacillaria respond to heat. Little ostracod there. But what I thought would be cool is to do a little bit of polarized light on these insect larvae. See if we get anything interesting. Check this out. Put this guy on and turn it down. Here we go. Polarized light always leads to some cool effects. It doesn't like it when there's a lot of little details moving around. Yeah. Wave played on. Okay, that's good to hear. Yeah. You know, live, you take the good with the bad. Whoa. What's going on with this thing? Here we're in polarized light. I've got a wave plate on top of my initial polarizer, which gives it some color versus directionality. And so anything with muscles, like these larvae here, tend to have cool effects. It's cooler when they move around, and you can kind of see the muscles contracting and whatnot. But for whatever reason, maybe these are kind of pinned down right now, not moving much. But man, this is just so like this is what I was talking about before. Of like in polarized light, often the like the outlines of stuff get bright, like the outlines of the cells of the spirogyra, and it just creates these really cool effects. I think they're just very pleasing to look at. Oops, turn on this one. Let's see. Oh, I wanted to try something. Yeah, let's see if this does anything interesting. Oh, we got some pink. Let's see, let's take this. That's what I usually do is turn this down. We get this one back to max. I'm talking to myself here a little bit. Turn it like that, and then let's put this on. This is kind of cool. It's sort of, I'm using a little piece of plexiglass here. It's an extruded 1 millimeter thick piece of plexiglass to sort of adjust the colors. And I figured, like I usually do this with cellophane, but maybe, ooh, this guy's starting to move around a little bit. I've been kind of wondering, like, okay, if I start using some other plastics, other materials, maybe I'll get other cool effects. That you can see those muscles going. So it's twitching. It's definitely twitching. Oh, hello. Maybe this guy just needed to warm up a little bit. Maybe it was too dark. Now that it's under the light, it'll start doing some other stuff. So let's see, that's the baseline basically. And then we can just kind of tune around. There we get kind of everything comes through. Well, this is looking like green purple. One of my favorite effects. Yeah. Like getting that. Like seeing that. Come on, start flailing around. No, you want to. There's that ostracod out. I'm sure that thing's... There's the ostracod, shining brightly. There's our other little chironomid larva. Get a little extra view. See the Bacillaria going around in there. These are nice. They're getting some cool effects. This is actually super cool here, where it seems to have like boosted the contrast on some of these spirogyra. It's just so neat. Like, this is like one of my favorite parts about microscopy, you know, is it doesn't have to be all about science necessarily and like trying to figure stuff out. You can just kind of entertain yourself by getting some cool visuals. Nothing wrong with that. This thing is definitely like significantly twitchier than it was before. Let's see here. We could just do darkfield just for grins. That is get rid of it there. Let's see. Oh, there we go. I don't know if we'll be able to get all the way up. It's close. Close enough, I think, actually. There we go. Wow, look at that. You can see, like, I don't know if that's vasculature or what. See something going on inside of there. Darkfield's always really great for kind of getting an X-ray view on, like, things like worms. Larva, anything that's kind of clear. Where's that big boy at? Yeah. Wow. Yeah, look at all that. Those little tendrils going around in there. I wonder what those are. They almost look like a nerve system. Here at the 20x. Wow. This is something else too, just to mention about like microscopy in general, is like I've had stuff like this before on slides, but just depending on how stuff is mounted and you know, how it ends up oriented versus you. Like, a lot of times you can see new stuff in familiar subjects if you take the time to look at them multiple times, you know, and don't just ignore stuff that you've seen before, because you probably haven't seen everything there is to see. Here's our little Bacillaria going. going on there? Is that a... Hard to tell if that's just a little piece of debris. I think it is. I think that's just a piece of debris. I think maybe it's a testate amoeba or something, but I don't believe it. I don't buy it. Hey, look at that. I missed you on the first pass. Oh, we got some coconis. This is a little vaginicola. A little Nassulid ciliate. It lives inside a lorica. Kind of like a mini stentor that lives inside of a shell. If we get a little tap, there we go. It recoils inside and then redeploys. Tap, tap. I wonder what the view looks like right now with the 40x. Let's see, probably need to come this way with it. Yeah, this will be a thin one. Got kind of a circular oblique illumination going on. I just like to see what there is to see when I do that. Unfortunately, I can't quite get rid of that, but that's okay. Circular oblique and a budget phase contrast. Okay, let's maybe say goodbye to this slide and go to our last slide of the evening, which is another one where I wait, is this the one that we looked at before? Enter. No. Yeah, so this is another slide. Oh no. I bet you guys can guess what this used to be. Poor little dude. Okay, I guess they're pretty oh, how unfortunate. So yeah, this is another slide where I attempted to make it very, very thin. And I found this teeny tiny hydra and I thought, oh, it should be thin enough. But alas, even for this teeny tiny hydra, it's too thin. But like I said, I do have some ideas for in the future of how to prepare slides a little bit more carefully. I have to say, it is kind of cool in a sense. Like, we have this this mashed up hydra here. I put a little extra water just on the edge of the slide to you know, encourage stuff. Is it still alive? Barely? It's almost contracting like it's alive, but I don't know. It looks not super happy, not super stoked. Let's go around. Up there we have, yep, here's another squish victim. Some kind of Varicella, testate amoeba. That was squished. Crushed. I wonder what happens to the amoeba inside when the shell gets crushed. I think there's some stuff on here that's, yeah, look at this. Ooh. Oh, that's an interesting little critter there. It's got some color to it. I think it's a paramecium. But it's, wow, look at that. Look at those fabulous purples that are going on inside of this thing. We're at the 20x objective right now. Wow. I remember seeing these things under the stereoscope and thinking that they did look a little odd, look a little dark. Wow. I wonder if they've just been eating something that makes them like that, or if that's a treat that they have. Wow. Well, this is a cool organism. Whatever it is, I like it. It is very pretty. Is that a little... That looks like a Certos. This is not a paramecium. I'll tell you guys that much. I don't know what this is, but it is not a paramecium. So I'm looking at, see if I can't. So if you see that sort of bright thing in the anterior of the organism, oops, that is some kind of oral apparatus. And paramecium have oral grooves. And that looks like a Certos, which is sort of a horn-shaped funnel. So that would make this like a Nassulid, but it kind of doesn't, it's not shaped like most Nassulids are. Wow, this thing's fire. I like it. I like this one a lot. While we are here, maybe we do a little polarized. We do a little polarizing. Oops. Bring that up. Let's check the orientation on this. There we go. Okay. And if we pop that in, oh my gosh, that was a little too far. There it is. I can see it. Oh, it is dark. Okay, I'm gonna move out of dark field. Oh, so it's not really, there's not a whole lot going on except for the Certos. Yeah, I've seen that before. You guys notice that Certos, that oral apparatus, oh, look at that. It just shines up so nicely in polarized light. It becomes very clear, very distinct. Here. This should be back. Crud. the 40x here. Polarization starts to not work super well with the 40x for darn optics reasons. Oh, dude, this organism is cool, and I believe this is a first time on the channel for whatever this organism is. So that's also cool. Oh, yeah, I think this thing seems familiar, to be honest. Okay, I'm gonna quickly try to get into DIC here. Don't swim too far, buddy. There we are. Oh, yes. Wow. Oh, look at this thing. Look at those purple nodules. They're so purple. They're so purple. Wow. So like, you know, normally I would associate like purple stuff like that with blepharismin, which is the pigment that gives blepharisma its kind of pinkish purple color. But I don't want to make that call without knowing exactly what this organism is. Oh, wow, this is so cool. This is a great organism. Oh, and I think in the middle, see, there's like a band kind of through the middle here that when it like rotates, there's no purple or anything in there. And I think that's the nucleus. It's sort of like a football shape. Big ellipse. Of course, I mean the correct kind of football. The kind of football that most often touches hands. Oh, my beaut. What an absolute beaut. This is a cool organism. Very happy we have found this one. You know what? Let's take the time to look at it in bright field. Down here, let's get that into there. Oh my gosh. Look at this thing. What a beaut. What a beaut. Kidding me? You silly? It's like filled with ink or something. It's so dark. Oh, damn. Fire. Okay, you know what? We haven't done it yet. Oh, look, oh, it pooped. We saw it poop. There we go. That's exciting. Yeah, the purple is so deep. Like, you know, because normally when something's this small, like the pigments, they just don't have, stuff becomes transparent. Like the fact that these things can become so dark is, I mean, whatever substance they're made of, it's very special. Okay, and here we are in phase contrast. That Certas shows up real nice. And kind of the purple gets drowned out a little bit with all the other kind of aberrations that go on when you do phase contrast. Oh, but you can, like the nucleus definitely does stand out. There's some stuff, or at least what we're calling the nucleus. There's definitely something going on inside of that that's different. Wow. Oh, well, this is just fire. Actual fire. Let's make sure this is good. Let's drop this down. Yeah, I think that's pretty decent. Oh, wow. Okay, that's a cool organism. What the heck is that? That's just some stuff. I don't think that's anything. Or maybe that used to be an organism. Maybe that's something that got smushed. I guess I do think there were some things that got smushed on here. We're gonna go look around. Like this rotifer got smushed. Sorry. Yeah, that rotifer is definitely too big. Another rotifer. We have a little isocline of bacteria emerging here. Okay. Ooh. Come in here. Let's add a little bit of water. This is a thing. This looks like a another Nassulid of some kind, but maybe not the purple boy. We can go to here. Turn that way down. Come to here. That way down. Pop that bad boy on there. Oh, this is... Oh, whoa. Look at that. It's clearly related. Clearly. I'm not a biologist, but I feel confident in saying that this thing is related to that other one. But it's got like actual black pigment. Wow. No way. Wow, look at that diatom. It's very pretty. Dude, these like super highly pigmented ciliates. What interesting critters. There's Cimbella. And, a little spinny. Got a little spinny going on here. Okay. Let's continue searching around. Ooh, hey. Okay, this is definitely a Nassulid. This is a classic Nassulid right here. This is typical Nassulid stuff. Let's see, I guess I'll put this on. Boost that up. Yeah. Oh, this way with it. Okay, Face. Have a good night. Thanks for tuning in. Yeah. So, Nassulids like to eat diatoms. Typically, anyway. I didn't see any diatoms inside of those other ones we were looking at. But this is very standard. When you see a Nassulid, they love these pinnate diatoms. And that Certos, which we can see that little circle there, that little funnel, that fits very nicely around these kind of thin little diatoms, and it's able to slurp them up, and so you get these like amazing little cellular blobs of diatoms swimming around as the diatoms are slowly digested, and then they will be kind of the shells will be spit out of the ciliate. Wow. Okay, let's go to DIC, I guess. I guess we can do some DIC. We can see the nucleus in the middle, big fat nucleus. And you can see the structure of the Certos really well. Oh, this is great. Really great imagery for live. I also really like this diatom, this like larger diatom inside of it. That's a pretty cool diatom. Maybe some kind of navicula. Okay, let's go ahead and we'll go back to the 10x here. And we'll just zoom around again and just see if we got any more cool little ciliates swimming around. Ah, here we go. Here's a nice little Nassulid. Might be kind of the same species as the one we just looked at. Yeah, this one got squished. Here's our our former Hydra. Oh, there's a little Hypatrick. Go at the bottom. Just quickly scanning around to see what we've got. Man, that purple one though, that thing is wild. Not the same one, maybe a slightly different one. Looks like we got kind of maybe 3 main ciliates on here. Let's see, we can go to the 4x. Look right, oh, those are nice. Sigmoides. Just kind of want to go find something quick. Ooh, we got a nice Closterium. Ah, yes, here's our purpley neuter. And another one of these Nassulids. Wow. This is so interesting to me. I remember picking up this little thing too. Okay. Oh, goodness. Let's I mean, it's kind of staying right here. Gosh, I just know this is going to be difficult. Okay. Well, it's staying in this general vicinity. So let's do that. And, oh, that's right. I gotta, okay, hold on. Please stand by. There we go. So I gotta put on my other turret to do this. So this is gonna be very difficult, but we're gonna make it work. We're gonna have to get a little bit lucky, but we'll try some oil immersion now. Oh, did it swim away? No, come on. Don't be like that. Yeah, stay around here. I put the water on this slide. And now this thing is like free. You can see it's a little more slender now. Now it's free to swim around, which is cool, but also a little annoying when you're trying to get to oil immersion. Easier when the things aren't moving much. One thing I could try doing is actually like deliberately squishing the slide down a little bit more. And I risk actually squishing it. Where'd you go? Let's see, I got a 10x here as well. Please stand by. Where'd it get off to? There it is. Okay, I think I maybe kind of was successful a little bit in squishing it. Just trying to get it to slow down a little bit here. Yeah. Okay. Let's go to the 40. Let's get it there. We'll set our hard stop. And we will just get ready, I guess. Let's first get ready. Let's open up this. Let's go to here. And we'll drop it down. Pop a little oil on. Boom. Come up to the hard stop. And see if we can't find... Hey, there it is. We'll chase it down in a second here. Okay. This is with my 60x. Thing is, this isn't really a lens that's designed for DIC with this condenser. I guess the other thing I can do actually, yeah, why don't we do that? We'll go full Monty with it here. We'll oil the condenser as well. Oops, I just dropped a bunch of oil on top of the condenser. It's great. Immersion oil never fails to be a messy affair. Put that off before it gets anywhere. Okay. And just bloop, plop that in right there. Get you right here. There we go. Boom. Bueno. Now we get the full numerical aperture of the condenser available to us. We'll try going back to DIC just to see what it do. So with the 60x, it's never quite, I never quite get like the modulation I'm looking for. Well, not bad. It's not bad. Yeah, you can see these These cilia are very sharply resolved, very more punched in. This is the nice thing about having a 60x 1.4 numerical aperture lens, is that you get very sharp resolution even at this high magnification. There goes a little bacteria there. I wonder. And we kind of hard to see there. And then we can also go to, let's reset this, drop this down, and we can go to my 100x. So the 100x has the same numerical aperture as the 60x, so this is just kind of a zoom in, more or less. Let's see, that up all the way. But it's not a digital zoom, so at least I still get the full fidelity of the camera sensor. Wow. Wow, they're so purple. They're so purple. What a beaut. Love it. Right, drop down, 60x in, go up. There we go. Same deal. You can kind of zoom around, see what else we got here. Oh, here's the rotifer. A rotifer that got smushed. Sorry, little rotifer. I wonder what, you know, while we're here kind of winding down the stream, I don't often do polarized light with these super high mags, so let's see what we get when we try that. Go. Yeah, Certos still shining. You can see these these cool diffraction rings that you get from those the few little birefringent crystals that it has. We are super duper down in the weeds now. Oh, get a little darker. There you go. Dang. Put the wave plate on there. Oops. Okay, this one is very touchy on that. Let me remember. Dead Frog, welcome in. First time on the YouTube. Yeah, we're probably winding down for the night. Got a lot of other cool stuff tonight. Okay, now we can just kind of shoot around the slide and see if we run into anything else. There was that other cool ciliate. That had the really dark pigmentation, but kind of going to be difficult to find that. Oh, here's a little flagellate of some kind. Always stumble onto the very small stuff when you go around with the Oil Imm lens. Let's see, we can safely use the 10x here. What the heck? Oh, that's in the oil. Yeah. And if I close this down, that gets rid of those. There we go. Sorry. Sorry, everybody. Like I said, I mentioned at the beginning of the stream, if anybody wasn't here, I'm a little bit sick. So there's a little hyper trick. Okay, we can try and find our friend. I think that's the condenser oil below that's like going around. Wheel. Oh yeah, here's the Vaseline. Oh, I can't find any of our other little friends, it seems like. Well, there's a Closterium that got smushed. Oh, there is. Oh, there's a. I think, is that the same one? Is that the one with the purple? I think it is. Yeah. I don't think that's the other one. Well, I might not have enough oil on here. Okay, well, I think I'm gonna go ahead and cut the stream here, everybody, just because they're gonna. I can feel myself getting a little tired here. I'm too weak to continue. So we will continue again next week. with I don't know what we'll have next week. I never decide where I'm gonna go until like at the earliest the Friday before, so we'll see. But thanks everybody for tuning in to another successful stream, and yeah, I'll see you next week.